Good morning and welcome back to AIEC Webinar Weeks. This will be the 6th, I believe, webinar in our series for the new year. Going to be on wildlife mitigations, solutions for preventing wildlife outages. Couple housekeeping items here. This presentation will last about 40-45 minutes. We'll leave 10-15 minutes at the end for Q&A. Please submit your questions to the chat function. You can use a little drop down, select AIEC, and direct those questions to Brian and myself. We will make sure to moderate those questions to our presenter today. Again, please keep your microphones muted. And also, just a quick reminder for those of you that maybe haven't attended one of our webinars or is new to the series this year. We did do a prize drawing last year, and if you would like to be eligible for that, please keep on the lookout for a survey from Ashley Graham. Make sure you get that filled out for us, and we'll make sure we put your name in the hat for our prize drawing at the end of this series. Brian, what do you have for us?
Just a reminder, this session does qualify professional engineers for PDHs. So if you haven't let me know, just shoot me an email, making sure I'm aware that you are interested in those PDHs so I can be sure to get those certificates sent out. I'm planning on doing it at the end of the 4 weeks, so you can have one certificate that can encompass all of the different sessions that you participated in. With that, our presenter today is Darren Barnett. He is the Senior Product Manager of the Wildlife Mitigation Business Unit for Hubbell Power Systems. Darren holds a degree in electrical engineering technology from Louisiana Tech University and has over 30 years of experience in the electric power distribution industry. Darren's career started as a design engineer for a major transformer and components manufacturer. From there, he advanced to positions of increasing responsibility, including quality assurance manager, engineering manager, and vice president of components operations. Darren is an active member of IEEE and was on the committee that developed the 1656-2010 testing guide for wildlife mitigation products. So with that, I'll hand it over to you, Darren.
All right, well, thanks very much. And to everyone that's on the webinar with us today, we certainly appreciate you taking the time out of your schedules to attend today. Appreciate it very much. So with that, I'm going to head into the presentation. So 20%, that's the number that represents why we were on this call, because approximately 20% of all power outages are caused by wildlife. And what I hope to do today is kind of a focus on wildlife mitigation as a solution, as it was indicated on the title slide. It's sometimes an afterthought, but wildlife mitigation products protect very expensive equipment and obviously keep the lights on for your customers. So we'll take a look at today some important features that should be considered for wildlife mitigation products, and also industry standards and resources that are available to you to help select wildlife guards. This pie chart is out of a study, a white paper published by FTI Consulting on wildlife mitigation. And it's a neat way to look at the impacts of power outages. I mean, it's certainly more than just the lights going off. So if you look at the pie chart, outages can affect safety. They can affect, obviously, the reputation of the electricity provider. They certainly can have a big financial impact, not only on the electricity provider, but on the connected customers that may be impacted by an outage. And also, certainly, compliance and regulatory reporting. So just a simple way, I'm not going to read all of the bullets, but just a simple way to think about the overall impacts of an outage. So energized risk points is where outages, animal contact can cause an outage. So these are just some examples of energized risk points. What you see over in the bottom right-hand corner of that slide is a G&W Viper recloser. And you see all the grounded structure around it and the terminals, you know, as many of them are shipped. In contact with those terminals and the grounded structure can certainly result in a power outage. More examples listed in the bullet points there, but basically anywhere there is an unprotected energized part that is within a bridgeable distance to ground or another unprotected phase, those are energized risk points. Very simple example, cutout, that's one of the more common contact points that causes outages. I think it's like probably second behind transformer, distribution transformer, pole type transformer bushings. But the application of the cutout guard, as you see on the right photo, mitigates the risk of contact and an outage resulting from that very common piece of distribution equipment. When you're considering bridgeable distance, which again is the distance that wildlife can bridge between phases or from an energized point and a grounded structure, it's important to think about the species that are in the region. This obviously varies by location in the country. California, they have to be concerned about condors that have a 9.5-foot wingspan. Obviously, bald eagles are present, 7.5-foot wingspan, many different parts of the country. And as you get lower on the list, those are obviously more common throughout much of North America. The hawk, the raccoon, and the animal that is responsible for the vast majority of outages on distribution systems, the squirrel. And 21 inches from nose to tail, that's not a small distance. So many different types of distribution equipment it can be compromised by a squirrel. One of the things that is very important and very critical to consider in selecting wildlife guards is air gap. And I want to briefly explain what air gap is, and then we're going to show a video that demonstrates this. Wildlife guards can't perform magic. What do I mean by that? That means that all they can do is insert an insulating high dielectric material in between the energized point and where an animal could contact. But where there are openings like cable exits and seams to allow for installation in that product, then that high dielectric material is not there. The wildlife guard must depend on air at that point, at all those points for insulation. So there must be a minimum setback. What you see on the top of the arrestor is the standard little cap that comes with many of them. What you see on the outside, the arrows pointing to the critical flash area. That's how far electricity at those particular voltages can arc or jump through an opening or a seam in a wildlife guard. So for a 35 kV system, there would need to be a minimum of 2 inches of air gap between any opening or seam and the closest energized point underneath that wildlife guard. It's a common misconception. Well, I've got a guard in place, but if the guard is not appropriately designed, it actually is not capable of performing its intended function, which is to prevent a flashover. This is a screenshot from the video that you're about to see. And there is the little arrestor cap that you saw in the graphic. And behind it is one of our ReliGuard lightning arrestor guards. So we're going to show the difference between the two and the importance of having the appropriate air gap built in. So what you see here, I'll narrate this. There is audio, but it's pretty low. These two arresters are identical. And the one on the right is obviously the little small arrestor cap that comes with many different types of arresters. The one on the left is our lightning arrestor guard. Both of them are energized at 18 kV. And this is what 18 kV looks like. So that's the arc flash distance for 18 kV. The crow is obviously grounded through its beak, its feet, and its tail. So our lineman here is just simulating an animal poking around on the lightning arrestor there, making contact. And there's the small arrestor cap. Again, it simply is not large enough to prevent an arc flash over anywhere there's openings or seams in the product. So just a couple of more examples of the importance of air gap. The photo on the left in this slide is is a set of oil sight glass bushings on a transformer in a substation. And you notice the offset connection. The connection doesn't exit in the center of that insulator, which is common. In substations, there are many different variables on equipment, much less standardization than there is on distribution equipment. And sometimes they're not constructed exactly per the drawing. So variations even exist at that point. What you see in the photo on the right is our Green Jacket product line. And you're gonna see today the two product lines, ReliGuard and Green Jacket, which Hubbell acquired in December of 2019. So both of these brands continue under the Hubbell Wildlife Mitigation Business Unit. So the Green Jacket product on the right is Precise Fit. It's custom made based on the actual dimensions of the underlying equipment, which we'll see how that's done in a little later in the presentation. But it's precise fit and there are very few openings. So if you look, it's solid everywhere except where the cables exit. And you notice that the air gap is built in with the flange. And then there's a seam on the other side like this that is actually open that also builds in the appropriate air gap. So precise fit, the air gap is automatically built in because it's made to fit based on the actual dimensions of the underlying equipment. What you see on the left here is a ReliGuard preformed guard. And preformed guards work well when they fit well on the underlying equipment. For distribution type equipment that has standard dimensions, they work well. In substations, there can be variances in equipment and inconsistencies that may not be preformed guard may not be the best solution. So if you can picture this guard, it's a mesh style design. If you can picture it being installed on that bushing as well, you can see that because of the offset nature of this connection, there likely wouldn't be 2 inches of air gap, and it would not provide protection from wildlife contact. So in this particular situation and others, which we'll see, Green Jacket precise fit would be the preferred solution and our recommended solution. So let's just talk a bit about Ieee 1656. This is a guide for performance testing on wildlife mitigation products. Now, this is very different from materials tests. Materials tests are a start for a manufacturer to select an appropriate material for use in whatever type of wildlife guard they're designing or manufacturing. What a materials test cannot do is demonstrate the performance of the actual final product, which is the reason all of the tests in this guide, and we're going to see those, are actual performance based tests, with the exception of one, which is the flammability test. So we had three things in mind when we started developing this guide, and I had the pleasure, or if you don't like sitting through long meetings for about eight years, then probably not pleasure, but I participated from day one in the development of this guide. We had three things in mind when we were developing this. Number one, we wanted to make sure that the ratings of the underlying equipment were maintained and not affected by the installation of a wildlife guard. Number two, we wanted to actually prevent contact from occurring, so a wildlife guard actually functioned. So the reason there's no image there, this is where I say, if you don't like seeing what happens to animals when they do make contact, now's the time to glance away from the screen. But there's the infamous arrestor cap that is not capable of preventing contact. When the squirrel is sitting on the grounded bolt of the arrestor, and all he had to do was simply get close, not actually even make contact with that cap. And number three, if we've accomplished the first two, we've demonstrated it won't affect the ratings of the equipment negatively, and it can actually work. If it doesn't last for the life of the equipment outdoors, in an outdoor UV, all kinds of weather, contamination, high winds, etc. If the design hasn't been proven that it will stay on, then we haven't accomplished much with the first two. So when we identified these three things as goals, we very quickly realized you can't demonstrate either of those three things by materials tests alone. So here are the tests that are prescribed and described in the guide. Cold temperature, effectiveness down to -25°C. Now that doesn't mean that just cold temperatures once it's installed. That means it actually needs to be functionable and installable and removable at -25°C. So that means any hinges, any latches, and all will function down to that temperature. Wind resistance to 60 miles an hour. Lots of debate about the ultimate wind resistance, but 60 miles an hour was decided on. And I will state that we test our designs to 50% above that to 90 miles an hour. Flammability, either the UL94V0, which you'll see that test being done a little later via video, or power arc are specified as the methods to demonstrate non-flammability. And then wet power frequency flashover is the test that determines whether or not a wildlife guard affects the withstand value of the insulator or the equipment installed on. Wet withstand is the test that you saw earlier in the video with the lineman that was moving the crow, except obviously it's not done with a crow, it's done with a defined probe on the end of a hot stick. And 26 kV would be the value of that test for a 38 kV system. So it's 20% above the line to ground voltage of the system it's designed for. Then obviously wildlife guards are outside permanently. So UV aging test is prescribed there. And then salt fog aging, which is identified as a test for unusual service conditions. Coastal environment or Midwest areas where there's chemicals and salt used for snow melt on roadways, heavy industrial areas, agricultural areas where there's a lot of environmental fallout, then that test would be prescribed. And it is 1,000 hours energized at 19 kV for a 35 kV system. So it's a difficult test. The guards are actually installed on the underlying equipment. So we saw the cutout guard earlier. It would actually be installed on cutouts, energized in a salt chamber for 1,000 hours. This is the last page in IEEE 1656. It prescribes the test And the important thing to note is these arrows in the column, the middle column here, those arrows mean that the wildlife guards proceed from one test to the next. So they're not individual standalone tests. You start with a set of wildlife guards here, and they progress all the way through all of these tests. You see UV aging is in the middle. Then the electrical tests are repeated after UV aging, then salt fog aging, and after salt fog aging, those two electrical tests are repeated again. So, no flashover is allowed in salt fog aging, but even after the aging, they still have to pass wet withstand and wet power frequency flashover. So it's a very comprehensive series of tests that demonstrate to you, if you specify 1656 compliance, it demonstrates to you the performance of the actual performance of the wildlife guards in a number of different areas. And an analogy I would use is, let's look at automobile tires. You wouldn't go out and buy a set of automobile tires just based on the type of rubber they are manufactured from. You would be concerned about a lot of other things, how they fit, what type of tread pattern do they have on them? Are you using them in snow? Are you using them in mud? All different kinds of questions that you would want to know about those tires that materials tests could not demonstrate. Same with wildlife guards. Materials tests simply can't demonstrate the performance that's needed in the field. This is the flammability test. Each test is described in detail in the guide, but we have a video that shows the flammability. Flammability can be critically important, or non-flammability can be critically important to wildlife mitigation products, especially in certain areas of the country. Anywhere there is a wildfire risk or concern, then wildlife guards absolutely need to be flame retardant. Because if they are involved in a flashover for whatever reason it might be, it could be vegetation contact, it could be some type of abnormal surge on the system. But if a flashover occurs and the guard is not flame retardant, it can ignite and not only damage the equipment that it's installed on, but also drop flaming material to the ground below. And certainly that in many areas of the country creates a significant wildfire risk. This is an example of the UL 94 V0 test. A defined flame from a torch is applied for 10 seconds. That's the reason the timer is going in the background, and then removed. And the requirements for a V0 rating is that the guard must self-extinguish and not drip any flaming materials below. In the actual test, there's actually dry cotton placed below the test samples. So as you can see, the guard on the right is not flame retardant, and once ignited, it simply doesn't go out. And so those flaming particles could be dripping on the equipment or could be dripping onto vegetation in the ground below. This is a shortened version of the video. If you want to see the full version of it, it is available for viewing on YouTube. So in summary, IEEE 1656 is comprehensive, it's sequential, it's test on actual parts, and there was very diverse industry participation in the development of the test guide. You see 52 names listed on the right side that were active members of the development of the committee that developed this guide. In very diverse participation, meaning there were utilities, representatives, manufacturer representatives, test lab representatives, academia, professors. So very broad cross-section of talent and industry participation in the development. So both Reliatanium, which is what ReliGuard preformed guards are made from, and Green Jacket formulations are proprietary, meaning that we don't buy them off the shelf from a plastics manufacturer. They are made for our formulations, for our chemical engineering founders, and that was the first order of business for both companies, was to develop a formulation that would meet the objectives of being UV stable, being flame retardant, and being track resistant for use continuously in an outdoor high voltage environment. And in addition to those, being able to be molded into installation friendly designs, meaning they're easy to install, easy to remove. And lastly, of importance to this group, both ReliGuard and Green Jacket are US approved. One other standard that I wanted to bring to your attention is IEEE 1264. I'm on this committee as well, and I will tell you the title is changing with the next revision. It will no longer be animal deterrence for substations because that was really not accurate from the beginning. So the title is changing to IEEE Guide for Wildlife Mitigation for electric power supply substations. And we just had our second virtual meeting, since we're not able to travel, last week, working on the next revision of this guide. John Randolph with Pacific Gas and Electric is the chair. And the next revision should be out before like 2024 timeframe. So what is this document? Just a few examples. It gives a lot of recommendations and guidance on different types of mitigation approaches for substations. Like this, for example, it talks about deterrence and the pros and cons associated with those. And it also presents actual data based on surveys that IEEE has done with utilities to determine the effectiveness of different types of mitigation. So if you went to this document, you would see the survey says that deterrents don't work very well for the long term. They're some of the lowest rated types of wildlife mitigation. And this is not based on IEEE ratings. This is based on actual ratings from end users. The IEEE simply gathered and tabulated the data. Animal fencing, these get rated very well for non-avian protection. Obviously, fences, if you have an avian concern, they're not going to do anything to mitigate that. And you have to be cognizant of the vegetation and what's surrounding the substation as well, or they potentially could be bypassed. Again, just additional type of information you would get from 1264. I don't really like this being called an animal guard. I refer to it as a barrier disc. And that description is being changed in the next revision as well. But these simply isolate an energized point from ground or from another phase. They don't provide any type of cover up or isolation protection of an energized point other than to block the path of touching. These can be very effective on different types of insulators, particularly on disconnect switches like you see in this photo here. Cover up, that's actually surrounding an energized risk point and preventing wildlife from being able to encroach close enough to actually make contact or cause a flash. And of all of the different mitigation types that are presented and where data was gathered by the IEEE, cover up was rated by end users the most effective all around type of wildlife mitigation protection for all different types of equipment. So just consider when you're looking at wildlife mitigation, it should be based on the actual data and experience that you have in your particular utility. Like we showed earlier, the distances, the bridgeable distances, some of those are going to vary by different regions of the country, and the types of solutions that you need can vary based on that, and also can vary based on the type of equipment that you're trying to protect, which obviously certainly can vary by end user as well. So this is an infographic that is in our product catalog for RelyGuard. It's not all inclusive, but it simply shows the many different types of equipment on a pole structure that we can cover with preformed, pre-molded wildlife guards. The dimensions are consistent, and preformed guards, when they're designed for that particular type of equipment, fit and function very well for wildlife mitigation. Again, not all inclusive, just a representative example of, from the top where the phase conductors are supported by insulators all the way down to the equipment that can be installed on the pole. We also, RelyGuard has many different types of pre-molded guards that can fit different types of equipment in a substation. From bus guards to different types of protection discs, to all the different sizes of bushings. We have bushing guards that are available anywhere from 4 inches in diameter all the way up to 10 inches in diameter. Many different sizes of conductor cover from 3/8 of an inch all the way up to 6.5 inches in diameter for bus cover. Regulator kits, terminators, lots of other things that exist in substations. And this is a rather unique product here that's shown in bullet number 16. It would actually go here. When a disconnect switch is in the open position, obviously the top portion of it is still energized. This particular one feeding the regulator is open, so this particular portion is not energized. But this creates a very enticing perch point for birds. So if a bird's sitting here, makes contact there, then it's an outage. So what this does is it's hot stick installable. It covers the open blade of the disconnect switch and protects from a contact across the two points. One other thing that we do at RelyGuard is provide one box, one part number kit solutions for different types of equipment, standardized equipment that exists on a distribution line. This particular one in this photo, that's an actual photo on the Detroit Energy system that is protecting a gang operated switch. So they order one part number, and the disc, the conductor cover, the lightning arresters, everything you see installed there, the cross arm guards for the insulator, for the structure of the switch here, all of that comes in one box. So the linemen put one box on the truck, and everything they need to protect that piece of equipment is in the box. We do that for reclosers, we do it for regulators, any other type of equipment that can be standardized. So we talked about performance testing. Some of the features obviously to look for when you're evaluating wildlife mitigation products are the features, not just the material that the products are made out of, but the features that are going to allow them to function and remain in place. For example, overlapping fingers, that minimizes an enticement for animals to use guards as food storage or for insect ingress into a guard. These fingers actually overlap and don't simply butt up against each other. Large, very robust latches that are glove friendly, meaning they can be opened and closed while wearing the required gloves. Optional permanent closure. not required to pass retention testing on any of our products that use other forms of closure, but they're there if your particular preference is to use a zip tie or a push pin to make it a permanent installation. 180-degree cable exits, meaning cables that don't exit straight won't cause the guard to tilt or gap open. It means the cable can exit the direction that it naturally wants to. And in multiple bottom opening sizes to properly fit different types of insulators, whether it be a transformer bushing, whether it be a regulator, some sort of standoff insulator, a breaker. The core diameter of the insulator, may be different, and for an optimum fit, we have guards available with different sizes at the bottom. So just some of the key features to look for when you are evaluating wildlife mitigation guards. Similar features on the cutout guard. These are just a couple of examples. There are obviously many others. Again, the 180-degree cable exit, overlapping fingers. But this is a hot stickable design, so the retention pin and the front closure can be installed from either side, whichever side provides the best access. And the design of this is made where it will not interfere with larger end of stick tools, such as a load busting type tool that's used with a standard cutout. This is the patented installation tool for our conductor cover that we call the Eel Slider. As you see in the photo, it makes it very simple to install the conductor cover while wearing gloves. That can be a very difficult task due to the large overlap that's required to maintain electrical performance. So this tool makes it very, very simple. There is a video available of this as well that you can look at. Also, installation video for the hot stickable cutout that we use, that we saw earlier, along with many other installation videos that are available. Green Jacket this says the solution for substations. It is primarily for substations due to its precise fit, custom-made nature. We talked about how equipment in substation can vary significantly from one station to the next, unlike distribution equipment, which tends to be very standardized. So Green Jacket is actually precise fit, made to fit the actual dimensions of whatever that equipment is. If you look at this example here, on breakers and transformers and things, the connections can exit at different angles, go in different directions. That might mean there might be 6 different covers produced for 6 bushings that appear to be similar. You see the very precise fit nature, fits to within 1/8 of an inch. So there is no gap, no potential for nesting, no potential for insect ingress, that sort of stuff. Also, Green Jacket can cover both grounded structures and energized wrist point. So in some situations, it's easier and better to cover the grounded structure. An example would be an air switch in substations. Obviously, you can't cover the moving parts due to they have to move and they have to close. So in that case, many times we'll cover the grounded structure of that switch and eliminate the potential of a phase to ground contact. So how is it done? This is how the dimensions are gathered. So you can see on this breaker the dimensional stick leaning against the equipment, and on the end of the hot stick on the left in the lineman's hands, you see the digital. This is a specialized digital camera that he's remotely controlling. So he will take images of this equipment with that measuring stick in view from all different sides of the equipment. And then those dimensions are fed into a photogrammetry program that actually creates a highly accurate three-dimensional model of that equipment. So that allows the production of guards that are precisely made for that piece of equipment and only that piece of equipment. So that means that Green Jacket, because it's designed only to fit that particular piece of equipment, in many cases can be capitalized and included with the purchase of the equipment for new stations when they're being constructed. So the end result, this shows what we call our site protection plan for Green Jacket. Once all of the dimensions are gathered and the scope of coverage or what pieces of equipment in a substation are going to be covered, once that is identified, and then the site protection plan is created. And when the Green Jacket product is delivered to the site, each and every piece, each and every guard or piece of coverage will be identified and labeled and matchable to this exact page in the site protection plan. So it's very simple to know where that guard goes, and any instructions that are needed for installation are also shown on that page. And because it's precise fit, it's almost impossible to misinstall it. It's precisely fit for the particular piece of equipment, so it goes on very easily, can be removed for any sort of maintenance that's necessary and reinstalled just like it came off. So one of the things that Hubbell has done is bring the two brands, Green Jacket and ReliGuard, together. Prior to the acquisition, Green Jacket and ReliGuard operated pretty much as separate and independent companies, although they were sister companies under Cantega Technologies. And one thing that Hubbell has done is brought them together in the substation type of environment. Green Jacket being a premium, precise fit solution, obviously more costly, but the absolute best solution for high risk substations. But we can also blend in ReliGuard product where appropriate, where there are budget caps to be met. Then ReliGuard can be used on certain types of equipment and certain applications in a substation. And that is determined not only based on the budget that needs to be met, but also the risk. So what do we mean by risk in a substation? Well, risk means really two things. The cost consideration of an unplanned outage for that station. So cost can include damage to equipment in that substation that occurs. Cost can also include the impacts of a connected load that's critical, where there can be a significant cost for every minute, for every hour that particular load is down. Lots of different types of manufacturing descriptions, airports, critical infrastructure and such. So the cost associated with an outage combined with the history of outages in the area, what type of species are there, have there been a lot of contacts in the region or at that particular station? And the further those two are toward the top and the right side of that graph, then the more critical we would consider that substation, and the more that Green Jacket would be the recommended solution for us. Lower risk substations that would be down in the bottom left corner of this graph, where they may be serving primarily residential loads. I don't want my lights to go out any more than anyone else's, but else does. But if there is no critical load and it's primarily residential, that may be considered a lower risk substation. So we can blend the premium precise fit and the pre-molded product to come up with the best solution for customers in a substation. So with that, I will end. I think we're hopefully about right on time here to leave some time for questions, but I want to leave the takeaway with you that cover up definitely works. You definitely can use wildlife mitigation, guards, cover up to really drive outages towards zero. There are several case studies that we can provide that demonstrate that wildlife mitigation guards, particularly green jacket in substations, can be very close to 100% effective. So cover up works, but absolutely the best fitting cover up works the best. So with that, I'll take any questions that have come in.
Thanks, Darren. We have had a few questions come in. So the first one, what is the best type of wildlife mitigation for disconnect switches?
Well, for disconnect switches, because they obviously have moving parts, they can't be insulated. You can't interfere with the movement of those switches. So for many different types of disconnect switches, if it's standard off-the-shelf disconnect switches, we would typically put barrier discs on the insulators toward the bottom to prevent contact from occurring phase to ground. For larger air brake switches and substations, as I mentioned, Green Jacket can cover the grounded structures of those switches. And in some cases can use barriers as well to provide face-to-face protection. So that's one of the applications where covering the energized wrist point is usually not possible.
The next question is non-flammability a requirement of IEEE 1656?
Non-flammability is not a requirement of IEEE 1656. There are two tests that were left as optional tests, meaning the end user should specify those where they feel it is appropriate. Flammability was one of those. It's left up to the end user to specify that they want flammability, the flammability test for IEEE 1656. The other one is energized salt fog aging. So if those tests, flammability, salt fog aging, are important, then those need to be specified in addition to the other core requirements that are required to meet IEEE 1656.
All right, and the last question, can wildlife guards be installed over more than one flight of an insulator?
Great question, and the answer is almost universally no, with very, very, very few exceptions. The reason for that is wildlife guards, although they are made from materials that are non-tracking, you saw that on the slide earlier, that determination of non-tracking is very different than for materials that are continuously in the presence of the leakage path from the high voltage terminal to ground. Those materials we call primary insulation materials. They are designed to be in between high voltage and ground long term. Wildlife guard materials are not. They are designed for incidental momentary contact only. And the sheds, the flights, the skirts, whatever term you want to use to describe an insulator, those are there to make the creep or the leakage path of that insulator longer, because electricity will track across a surface at a much greater propensity that it will flash or arc through the air. So if you install a wildlife guard over more than one skirt, then you are taking the leakage path, those flights out of the circuit and inserting instead a wildlife guard material that is not designed for that. So the higher the voltage, the more critical that is. It can certainly lead to a flashover or a failure of that insulator over the long term. especially at higher voltages, you know, that would exist, like say a 35 kV system where you can, you know, you have 20 kV to ground. So it's critical that manufacturer's instructions be followed, and I do not know of a manufacturer that would recommend shorting out or covering more than one flight of an insulator.
Well, thank you very much, Darren. We appreciate your time today. It's definitely nice hearing from you and some really good information in there. Real quick, if someone would like to reach out to you, do you have some contact information that you can put up on the screen, or maybe throw us your contact information, email address?
Yeah, I certainly will. It's quite simple. Unfortunately, I probably need to add that. I don't have it where I can put it up right now, but it's dbarnett@hubbell.com is my email, and I will send you the other Hubbell team members in the area as well.
Sounds good. We appreciate that, Darren. And for our listeners, you know, you can always reach out to us here at AIEC, and we can definitely get you in contact with Darren over there at Hubbell Power Systems. So again, Darren, thank you very much for your time today.
All right. Thanks, everyone.
Up next, we have, at 1 o'clock, we have Building an Active Grid with IoT. If that sounds interesting to you, please join us at 1 o'clock. You can always go out to AIEC webinar weeks to register for that. And if registration is closed, please reach out to Ashley Graham and she will get you taken care of. Thanks for joining us today.